Dear student, in this session we will discuss a subtopic 1.2 different types of operating system from unit number 1, that is overview of operating system. In this session we will discuss the real-time operating system. It is defined as a data processing system in which the time interval required to process and response to input is so small that it controls the environment. So this is the basic definition related to real-time system. That means whatever the input we are giving within a small time period, the output is expected from the system. Some of the examples related to real-time systems has been given over here. That is the microwave oven, traffic management, security system, then audio system, then missile system is there, then automatic car driving is there. So these are some of the examples. To illustrate the use of this real-time system, consider an embedded system for controlling a home dishwasher. Now, this particular embedded system may allow various options for scheduling the operation of the dishwasher. That is the water temperature we have to set, then the type of cleaning we have to set, that is light or heavy, or even a timer we need to set indicating when the dishwasher has to start and when it has to stop. So this is what we call it as it controls the environment. Another example we can discuss over here related to the real-time system is the automatic car, in which when the car get drive automatically by starting the button without the human being or human driver, then many a times hurdles comes in between or arises in between the road. That is the some another vehicle may come up, or certain person may come up, or certain speed breaker may come up. So we have to apply the brake at the proper time and for the proper amount of time. So this sort of system is also called as the control by the controls the environment. So it is used when the rigid time requirement placed on the operation of a processor or the flow of data. So we used to say that the real-time system is subject to real-time. What it means that the response should be guaranteed within a specified timing constraint, or the system should meet the specified deadline. So within the specified deadline, the system must respond or the system may get fails. So the ability of operating system is to provide a required level of service within a bounded response time. So within a second, the system must respond over there within the real-time systems. So real-time operating system responds to system immediately. Now basically the real-time system is categorized into two types, that is the hard real-time systems and the soft real-time system. Some of the common examples of the real-time system has been mentioned over here. That is the traffic control, flight control, real-time monitor and so on. So one of the example again we may discuss over here is the traffic control signal. That is the certain timing constraint is placed onto the glowing of the light, and till that particular amount of time the people has to stop or move onto the road or onto the square. So this is what we called it as a traffic control signal. Now the real-time system, since they concentrate on a fewer task or a small processing operation, so very less amount of memory it occupy, and also consumes very fewer resources. Since the time constraint is there, so we know, or the response times are highly predictable in the real time system, because within that particular amount of time the system has to respond and give the expected output. And due to this, the performance is an important factor required to be considered while selecting for the real-time operating system. One of the drawback we can say related to real-time operating system is it concentrate on a few tasks. So many a times we have seen, say for example, the washing machine is there. In that, only certain operations we have to control related to the timing as well as the load of the um, uh, washing machine, and the type of the operation, that is heavy, light or medium. So fewer we concentrate onto the fewer tasks, and rest of the mechanical devices that are available in the system, they work at their own according to the instruction or the task set by the operating system. Then let us see the hard real-time system. So in this, it has a stringent requirement guaranteeing that critical real-time tasks be completed within a deadline. So this type of system can never miss the deadline. So this is very important. In the hard real-time system, it is expected that they should not miss the deadline. So missing the deadline may have the serious injury, or worst might may occur. So that's why it is very important to uh, never miss the deadline. So it also may have the disastrous consequences onto the system. So a hard real-time system has time critical deadline. Otherwise, the failure may occur, or certain serious injury or the worst situation may occur over there. That's why it requires the formal verification guarantee that it meets its hard deadline. In these systems, the secondary storage is of limited size or missing, and the data is stored generally in the ROM or the cache memory. Virtual memory is not present in this type of operating systems. Some of the examples mentioned over here are the air traffic control, missile launching system, in which say for example the launching of missile system is there, and no delay should be there in the in executing the instruction. So as soon as the missile is launched, it is expected that it get launched into the space. Then satellite control system is there, nuclear power plant control system is there, then the airbag control in car is there, and the flight control system is there. So these are some of the examples of hard real-time system. Even in the airbag control in car, we know that as soon as the accident occurs over there, it is expected that the airbags get open. Otherwise, the person may get died over there. So this sort of systems are very particular related to the deadline. Then another type of system, real-time system, is the soft real-time system. In this, it is less restrictive, providing that a critical real-time task will receive priority over other tasks and retain priority until it's complete. It means that this type of system can miss its deadline occasionally. So missing the deadline will not affect the system that much. So no deleterious consequence may happen over there when we are making use of the soft real-time systems. All the modern operating systems can serve as a base for the soft real-time systems. Some of the examples, that is the personal computers in which the different processes are there, instructions are there, and one after the another the instructions or the processes get executed depending on to the priority of the instructions and completing the task. Then multimedia transmission and reception, that is downloading, sometimes downloading the audios, videos, and hearing those. So some sort of delay is obvious in such situation. In networking, in telecom network, in websites and services, in computer games, and in telephone switches. So these are some of the examples in which the less restrictions are there onto the time, but one after the another, as soon as the task get completed, the operation are expected to get completed. So this is all about the hard real time and the soft real time system. In next session, and that is the last session, we will discuss the mobile operating system, that is the Android and the iOS. Thank you.